maybe with actually this thread of like the exponential that's happening in robotics. And I'm curious to get your point of view as far as maybe what's driven that, or like where we are sort of in the exponential curve. And obviously Figure's been like paramount, like sort of on the front line of that exponential. So it's been awesome to see all the progress from you all.
Yeah. So I have like kind of two companies that do like kind of electrical mechanical hardware work, both at Archer, just with like electric VTOL aircraft, and Figure. We build like electric humanoids. I think there's like two things that are really, I think, different now than it was like 5 or 10 years ago. I think the first is we've been able to build, in the robotic space, or even maybe specifically to humanoids, we've been able to like really capable hardware. Like the body in this case is for us gotten like extremely reliable. If you come to our facility and like walk around, there's robots like everywhere. I think there's one one walking behind me in a minute here, and the robots are just like super like the reliability of the hardware has gotten really good. Both in like the commercial setting when we have robots deployed into a customer, and even our facility. So if you were here walking around, you'd see like a lot of robots, and I don't think you would see a single like hardware failure throughout the whole day. We rarely see like events like this. We do have them. It's just like I think it's just become like more and more rare. So I think even if you have like the best AI in the world, you need like you can't get this done on like mediocre hardware. It's got to be really, really capable hardware. So that's the first thing. I think we've been able to build like electromechanical systems on the hardware side that are really going to get reliable. Like reliable of like you have a very complex mechanical system, complexity is very high. So like up there with like rockets and turbofans and other type of sophisticated hardware. But we've been able to build like extremely reliable turbofans and turbojet systems like here in the world. And I think the same for humanoids. Like in the next I would say that even in the coming years, the humanoid reliability is going to get really capable and really good. So that's the first thing I think has been really helpful. Is like we now have like really good hardware. And 10 years ago, you didn't have that. I mean, like the best robot in the world 10 years ago is probably like Atlas of Boston Dynamics. And that was a hydraulic system, so it only ran for 20 minutes or so. It leaked oils everywhere. Had probably a few thousand psi. Every like valve there, hydraulic valve was about maybe 2,000-3,000 psi. It's like extremely dangerous to be around next to a human to the extent that leaked. But now we have like electric systems that are like I would say safe and like reliable. Kind of like heading down that trend, I guess. And then the second thing I think is we have like robotics is really like a neural net problem in the limit, and we really haven't seen neural nets do well in robots. Until recently, almost like the last several years. So we have we now have neural nets running on board robot that are commanding, basically hand positions, head, torso, like basically the whole basically action space, the robot. And it's working really well. Like you're watching, you can watch some updates from us, and you see we put an update out like a week ago or so of a robot just doing 60 minutes of like continuous logistics work. That was a single like S1 Helix neural net that we're running on board the robot, and it's just like it looks like what a human would do in some way, like almost like imitating like very similar characteristics of what a human would have, and we're approaching like human speed and performance of that robot. So that's also something I would say 5 or 10 years ago you just didn't have. So in the case of robots, we have like neural nets working, and I think hardware is getting like more and more capable in general, which is like kind of the two big inputs you really need to make this work.
Yeah, I'm curious about this. I don't know all the historical perspective on Figure, but was the intent always to like jump straight to humanoids, or like was there? And I think about this through the context of I just got a Matic home vacuum cleaner robot, and it's like materially better than any of the other robotic vacuums that I've tried in the past, and like it feels like very close to this sort of future of what you might imagine home robots looks like, but it's like obviously vastly different than a humanoid robot. It's super limited in what it can do, et cetera. So I'm curious, like sort of your headspace as far as like the path to make humanoids work. And obviously you all have taken the approach of like go straight to humanoids.
Yeah, I went straight to humanoids day zero. I wrote like a master plan, like basically like a vision doc. That's on the website now. The first day I incorporated with Delaware, I wrote that and put it out. So I wrote it the first day I started the company, and like for me, like it's like the ultimate meta problem is like trying to solve humanoid robots. So like you have to just go right at it. Like there's some other options of like putting wheels and other type of end effectors like claws and other things in the robot, and it's basically a local maximum. Like it'll put you. It'll basically be like it'll be a significant issue trying to get to where you really need to go if you're not designing straight for like the right system from day one. It's basically going to act like a huge crutch for the business. So I thought like my thesis like 3 years ago was that it was possible to go do this, and so we basically like started just building and designing human